A revolutionary design concept, built to break records by a legion of brave men. Protected by an aluminum skin, it boasts the highest rooftop in the United States, with its roots deep in the bedrock of Chicago's land and history. Now, the Sears Tower on Modern Marvels. More than 25,000 people walk into the Sears Tower every day. It takes 104 elevators, some double-decker, to transport workers and visitors to the 110 floors of the tallest building in North America. The Sears Tower was considered the tallest building in the world until 1998, when the Petronas Towers in Malaysia surpassed it by 33 feet, but only with the help of decorative spires. It rises 1,450 feet above the city of Chicago and has one of the most impressive observation decks in the world.
When people come up to the Sears Tower sky deck, on a clear day, they're able to see up to 50 miles, so you're really not just seeing downtown Chicago, you're also seeing the rest of Illinois, Indiana, Wisconsin, and Michigan, and it's just an amazing, amazing view. And with the Sears Tower being the tallest building in Chicago, you're looking down on this amazing architectural mecca that is Chicago.
More than 1 million tourists come to visit the sky deck annually to take a multimedia elevator ride up to the top.
The Sears Tower Observatory has some of the most unique elevators in the world. First of all, they're two of the fastest. At top speed, they're going 1,600 feet per minute, and you start 2 levels in the basement and come up to the 103rd floor in about 60 seconds.
The 4.5 million square foot skyscraper, located in the heart of Chicago's Loop, includes offices, a private dining club, conference facilities, a U.S. post office, retail stores, and restaurants.
It is a length of close to 5 football fields. There's 2,232 steps to get to the top of the building. There's 796 lavatories.
It takes 110 janitors, 100 security guards, 25 engineers, 3 electricians, and dozens more to maintain and operate the 50,000 miles of electric wiring, 25,000 miles of plumbing, 80 miles of elevator cable, and 145,000 light fixtures in the Sears Tower. Tony Tonian has worked at the Sears Tower for 13 years and is responsible for operating the 6 automated window washing rigs that scale the black exterior to wash the 16,100 windows.
For washing the windows, the window head will jut against the window with this first squeegee knocking off the bulk of the heavier dirt. Then we have spray nozzles behind it that spray water onto the window. Then the brush will knock the rest of the dirt loose, and then we have 3 squeegees behind that's connected to a vacuum that vacuum the water off the window.
As long as the air temperature is above 25 degrees and the winds don't kick up above 30 miles an hour, the windows are washed year-round.
When you think about maintaining the comfort level in a building this size with so many floors, you go on a main street downstairs, it could be 65 degrees. You come up to the 78th floor where I work, it may be only 50 degrees. There's a difference in temperature. People don't think that the engineers have to be involved to compensate for this different temperature.
In fact, there is a staff of operating engineers who closely monitor the heating, ventilating, and air conditioning units located on floors 29 to 33, 64 to 66, 88 to 90, and 104 to 109. These floors are considered hidden because they can only be accessed by the freight elevators.
All the refrigeration for the entire building comes from this location. I have a total of 5 chillers here. These chillers are equal to 4,800 tons of refrigeration. Now picture in your apartment or in your bedroom you have a 1-ton air conditioner sitting through your window. One of these chillers are equal to 4,800 of those.
With 3,000 thermostats throughout the building, plus the computers and lights used by the 10,000 tenants. It's a wonder that the Sears Tower has never lost power. In fact, the two standby 2,100 kilowatt generators, which can supply enough electricity to power 200 homes each, have never been used. With that much potential power, the Sears Tower was built to last. And in 1968, when Sears Roebuck & Company decided to build a new headquarters for its growing company, it was going to be built big.
Sears was the dominant retailer in the country. He had been #1 for a long time, and we far exceeded the competition, which in those days was JCPenney and Montgomery Ward. And Sears' growth was just phenomenal. But it was because after the Second World War, Sears envisioned the use of the automobile and the advent of the suburbs. So we were building stores like crazy on the fringe of cities.
And if you're going to be Sears, you're going to be the biggest, you certainly can't build a small building as your headquarters, you know. I mean, if you're the biggest retailer, the biggest, baddest on the block, you need a big place. They needed the space because they're just a huge company, but I think they were looking at wanting to make a statement.
About 70 years earlier, this big company got its start in a small town called North Redwood, Minnesota, with a railroad station agent named Richard W. Sears. Bored with his job, he created a mail order business and then a watch company on the side. In 1887, after moving his business to Chicago, he placed an ad for a skilled watchmaker and found Alva C. Roebuck. Later, a partnership formed, and by 1893, the two created Sears Roebuck & Company, a catalog business that catered mostly to farmers in need of general goods.
So the catalog was right from the beginning. Everything was done through the mail. And Richard Sears knew how to do that because of his experience with the railroad. So he knew how to move material and use the mail and that sort of thing.
Business grew so fast that by the turn of the century, Sears leased additional buildings all around Chicago and constructed a building affectionately named by Sears employees, the Great Works, a 40-acre, $5 million campus-like complex on the residential west side of Chicago.
When the building was built, it actually was the largest commercial space in the United States. And from what I understand, it might have been the largest in the world, which just gives you an idea of just of the magnitude of what Sears was doing, you know, how their business had expanded by the size of the buildings that they occupied.
But even the Great Works wasn't big enough to contain Sears. In 1968, with over 7,000 employees scattered around 10 locations in Chicago, Sears chairman Gordon Metcalf decided to bring the company under one very large roof. Since the building was going to be constructed by its owner for the company's own use, Sears planned from the inside out. Before even selecting an architect, they hired SLS Environetics, an interior design firm from New York, to perform studies on how much space Sears really needed.
We wanted to know how much space would we need, both initially when we moved in and also 30 years down the road, because it was planned that this building would be big enough to encompass our growth for 30 years. And Environetics was very much involved in that process of planning. Then later on, they were involved in determining how the Sears floors would lay out, how they'd be configured, the relationship between departments and so on.
After conducting interviews with department heads based on detailed questionnaires, and taking meticulous inventory of all the existing furniture and equipment, Environetics fed its data into a computer to analyze the company's total anatomy.
Literally, there were 90 or to 100 interviews that were then converted into space requirements for every individual listed in those questionnaires.
For example, a buyer would be 150 square feet. A vice president would be 300 square feet, whereas a clerical worker would be 50 square feet. So you had all of these projections and you moved them out into the future, and that's what led to Sears deciding that in 30 years they would need 3.5 million square feet. And that became the size of the project, even though at the time we were going to move in, we'd only need 2 million square feet.
Armed with computer-analyzed growth projections, Sears left the suburbs and chose a 3-acre site in the garment district on the southwest edge of the Loop on which to build their future headquarters.
We came downtown, looked at a number of sites, But the one that was finally chosen was almost ideal in terms of public transportation. It had access to all the suburban railroads and also the bus network. So you couldn't probably have found a better place in terms of letting your employees get to work in the most advantageous way.
They were loyal to Chicago, and so they wanted to stay in Chicago, and they felt that if they stayed in Chicago, they were going to be able to attract the best talent.
Sears was looking for talented architects as well as talented employees. And where better to look than the birthplace of skyscrapers? Chicago. After all, where else could one find a designer bold enough to plan a building great enough to become the home of the world's biggest store? The Sears Tower building site had one problem. Quincy Street ran through it. For $2.7 million, Chicago sold that section of Quincy Street to Sears, and the problem was solved. The Sears Tower will return on Modern Marvels. By the late 60s, Sears had grown to become the #1 retailer in the world. As a result, they had outgrown their current headquarters and were now ready for a new home. A great deal of work went into choosing the building site, but the choice of who would design their new home came effortlessly.
Skidmore was chosen as the architect because at the time they were the preeminent corporate builders of office buildings in this country. They had done a number of great buildings and they had the most talent.
That distinction was to the credit of two partners at Skidmore, Owings & Merrill. Bruce Graham, an innovative and outspoken architect, and Fazlur Khan, a modest but brilliant structural engineer.
Bruce and Foz collaborated quite closely in the design of a number of buildings throughout the 1960s, and eventually it led to the design of the John Hancock, which is a very tall building. It was this kind of dynamic energy that existed between the two of them.
The two often met outside of work to discuss different ideas. And while eating lunch one afternoon, they hit on the design that would become the Sears Tower.
We were pursuing the idea of the bundled tube system, and Foz was trying to describe this to Bruce. And finally Bruce says, "I think I understand what you're saying." And Bruce was a smoker and took out his pack of cigarettes and took out a number of cigarettes and kind of held them in his hand and had them coming to different heights, and asked Foz if this in fact was his idea, if this is what he was thinking the system might look like from an architectural standpoint, from a visual standpoint. And Foz said, "That's exactly right."
The idea of using tube construction was just starting to gain momentum in the architectural world.
Up until about 1960, most buildings were built with very wide spacing of columns in long spans between them, and these were called frame buildings, and that was the system that was used for many, many years.
Steel frame construction relied heavily on internal support columns and bracing to bear all of the structural loads. The size and number of these support columns directly correlated with the height of the building.
As buildings became taller, we realized that in fact this frame system was becoming very inefficient, as can be demonstrated by the Empire State Building with its very large quantity of structural steel.
Fazlur Khan was best known in the architectural world as the father of tubular construction. His idea was to bring the exterior columns closer together so that the columns would act like a wall on the perimeter of the building. This would minimize the need for massive support columns in the center of the building. The Hancock Building, as well as the World Trade Center buildings, were both designed using this new construction method.
The idea for Sears Tower was that since this was such a large building, the tube started to become inefficient because it was so wide and so deep. So the idea was, why not take multiple tubes and put them together, bundle them? And so Sears Tower, if you look at a floor plan, is a series of 9 tubes, 3 by 3, that are bundled together.
At the base of the building are 9 tubes. 2 of the tubes end at the 50th floor. 2 more tubes end at the 66th floor. And 3 tubes drop off at the 90th floor, leaving only 2 remaining tubes to proceed to the top.
This bundled tube concept very easily enabled the architects to create this modulation of space as they went up. And the purpose of that was Sears required very large floors for their function, but they were only going to initially occupy half the building. The remaining half, or the upper half, was going to be leased to tenants. So the idea of dropping off these various tubes then resulted in a smaller floor plan, which gave more perimeter offices and was therefore much more attractive on the leasing market.
The bundled tubes, as well as the ingenious use of step-backs, set the Sears Tower design apart from earlier skyscrapers. Breaking records was just an afterthought.
The decision to become the tallest building was not part of the initial program. But as you started to build floors that were smaller than the 50,000 square foot Sears floors, you started to build smaller ones to attract tenants. You started to push upward to encompass the 3.5 million square feet.
And soon, the Skidmore, Owings, and Merrill team found themselves with a structure that was just flirting with a world record.
I went into a meeting with most of the Sears executives and the architects, in which there were a number of cardboard models. And then out of a bag, Bruce, who was the consummate salesman, pulled out this walnut model and put it on the table and suggested that we were so close to the ultimate, so close to the world's tallest building, that we should consider going for the brass ring. And the Sears executives almost broke into applause. I mean, there were smiles all around the table.
Just a few weeks later, on July 27, 1970, Sears management publicly unveiled the model for the Sears Tower. A model for a building that would reach 1,450 feet into the sky. The model for the tallest building in the world.
The public was pretty excited about it, and I think most of the excitement came from the fact that we were one up on New York. Chicago was the birthplace of the skyscraper. It had always prided itself on its tall buildings, and that thunder was stolen by New York.
The World Trade Center buildings were currently under construction in New York. They had been designed to be the tallest in the world. And now, the competition was on, and Chicago was poised to bring the title home. Ground was broken in August of 1970.
We started almost immediately. I didn't have finished working drawings. I had finished working drawings close to the day that we would start that particular phase of the project, so that the foundation drawings were finished before anything else, and that's when we started the foundations.
By midwinter, work on the foundation site was well underway. The foundation plans called for a 3-foot thick wall to be dug around the perimeter of the building site. Bentonite clay slurry, an aqueous mixture of insoluble clay, was poured into the excavation panels as they were dug to prevent ground collapse and water infiltration. The panels reached over 5 stories into the ground. The slurry was later displaced by concrete and pumped out of the foundation wall. With the concrete foundation wall in place, the entire site was then excavated to the depth of over 50 feet. To complete the foundation, 114 reinforced concrete caissons, which varied in diameter from 6 to 10 feet, had to be dug an additional 50 feet into the earth.
Only the tallest buildings in Chicago are required to go down to bedrock because of the load. And what these are, they're drilled shafts that extend down to the rock. There's a steel jacket, and then they're filled with concrete. And there's one of these located under each column.
A 5-foot thick concrete mat was poured at the bottom of the excavation site. This mat tied all of the caissons together and became the bottom floor of the Sears Tower. With the roots of the superstructure planted firmly in the ground, the Sears Tower was ready to soar. One of the architectural design ideas that was considered for the new Sears headquarters was a large square building that was just 80 stories tall. This short and stout design was referred to as the Pig. The Sears Tower will return on Modern Marvels. By By June 1971, with the Sears Tower foundation firmly in place, the ironworkers were called in to do what they do best: build into the sky. Today, these men still take pride in their contribution to the Chicago skyline.
Mainly, the ironworkers on the Sears building are all members of Chicago Local Union Number 1. But there are also ironworkers who came from all over the country who wanted the opportunity to work here and say, have the bragging rights to say they worked on the tallest building.
Their jobs were made a little easier. In the interest of time and efficiency, the columns and girders would be welded together off-site at the fabrication plant. These prefabricated tree units were delivered to the site to be raised and bolted together.
The steel system was just wonderful. I mean, it went together as smooth as silk. The columns themselves had half of a girder attached to it so that you had the long column and then you had 2 floors of girders sticking out.
Transporting the tree units was no small task. The largest width that could be transported through the streets of Chicago was 10 feet. This width was too narrow to be used effectively in the building. The fabricators came up with an ingenious plan of skewing the units at a 45-degree angle on specially modified trucks, with the girders hanging just inches off the ground between the tires. They could now increase the size of the units to 15 by 26 feet and still make the journey to the job site with little disruption to the city.
These 3 units were brought directly from the fabrication shop. They pulled up at the base of the building, and these 3 units were directly lifted off the truck and erected immediately. There was no storage on the site. And the exercise was no more than putting together a whole series of Tinker Toys.
Every piece was numbered and loaded on the truck at the right time so that it would be the next piece to go up on the building. So it had to take a lot of coordination between the fabricators and shipping and the truckers to make it all run smooth, and everything had to stay in line.
Since the major work of welding the beams to the columns was done off-site, the ironworkers were able to easily accomplish an impressive 2 floors a week.
The raising gang sets the steel, they put 1 bolt in it. The bolt-up gang came up behind us, stuck all the bolts in. Then the plumb-up gang comes and they have an engineer with a transit and they straighten the building out, because if they didn't, it'd go out this way and that way. And then once they got it all plumbed, they tighten it up with the impact wrenches, then the welders take over, and that's how the building's put up. Everybody has to work as a team.
But the project would not be without its share of mishaps.
One of the incidents that took place during the construction of the building, we were erecting steel on about the 54th or 55th floor. And it was about 4:30 one afternoon, and my phone rang. And our field representative was on the other end, and he said, "I think you better come out to the building right away. Something happened here."
The sheave or the pulley down in the basement exploded, and it cut the cable, and it dropped a, was it pretty
7-ton column?
7-ton column,
yeah.
40 floors.
And the guys all heard that, and they looked and they saw what happened, and they all ran in and got under the building, and the column came down under the pedestrian walkway, and some of the cable hit the taxi cab out in the street.
Crushed it.
The superintendent got a bunch of iron workers, and they got that cab out of there, and they got everything straightened out so that it wouldn't make a big scene for the news media.
It was right at 4:30. Everybody was leaving work, you know, and all the office people.
Yes.
And that poor cab driver, he had his hands on the wheel. I don't think we can get his fingers off the wheel because all the cable attacked his cab. He just happened to be just sitting there in traffic, and all of a sudden, boom, he's getting eaten up by this cable.
They said the woman, the passenger that was in the back seat, wet her pants.
The amazing part of this story is no one was hurt, no one was scratched. The cable landed on the hood of a taxi cab, and that was the worst thing that happened.
Other accidents later in the construction had more tragic results. There were a total of 6 deaths on the entire project, including the death of 1 ironworker. By the summer of 1972, with over half the building below them and hundreds of men working on the project. It would take sharp planning and exemplary resourcefulness to keep the project on the fast track.
We needed the cooperation of the unions, who would work on a staggered start, staggered stop, staggered lunch. You needed the cooperation of the men who were willing to take meals off of carts that we brought up into the building. Medical staff, we had our own medical staff and first aid offices throughout the building. Another methodology that was utilized kept the building on target from a timing standpoint. Otherwise, if it had taken you another day of floor, you could see what the difference would have been with regard to the overall schedule.
The faster the iron workers set the skeleton of the building, the sooner the other trades could get in.
I believe you broke a lot of records for tonnage set in one day. I remember one day when we actually set over 100 truckloads in one day.
Yeah, from the top of the building, if you looked south onto Canal Street, the trucks were lined up because you couldn't block up downtown streets. It looked like Rommel's army in World War II with a line of trucks. And they'd come in, then we'd unload it, boom, that truck would go, they'd call in another truck. It was something. It's something I'll always remember.
As the building climbed, the workers found themselves fighting the forces of Mother Nature in their struggle to claim their share of the sky. They found that the weather at the top of the building could be drastically different from that on the ground.
In the morning, the ironworker steward would go up early and check the weather on top to see if it was fit to work. And sometimes it would be nice down below and the sun shining and not a lot of wind, and the steward would come down and say, "No work today, boys. The wind is blowing too strong up there," or it's maybe 20 degrees colder and it was actually too cold to work.
Dozens of work days were lost due to wind, snow, or temperatures below 10 degrees. From August to December 1972, iron workers were unable to work a complete week. Yet even with the setbacks, the structure continued on its journey to top the world.
During the whole process of building this, we would get reports from New York that were saying that they're going to add floors or a penthouse to one of the World Trade Center buildings, and that building was going to surpass Sears in its height, but that never happened. It was just a rumor.
And fittingly, on an abnormally cold and windy day, May 3rd, 1973, the building was ceremoniously topped off.
The topping out ceremony involved the man, Mayor Daley, who was like God in Chicago, and all of the top Sears executives. We had some Congress people, some show business people. It was a very big ceremony because this was the largest building in the world, and the mayor was very proud of it, Sears was very proud of it, and it was a big deal.
But center stage in the ceremony was the final beam. Painted white and signed by over 15,000 Sears employees and construction workers, the final beam was hoisted up the building.
I happened to be running the engine that day, and when I got to the 76th floor, I figured, well, I'm in control. So I put the brake on, I stopped it, and I went out there and I took a picture of the beam, got back in the cab and raised it up again and took it to the top.
The job of the iron workers was completed, and the skeleton of the Sears Tower stood triumphantly 1,450 feet into the sky.
I believe it was said that there was well over 1,000 construction workers on the job at one time, all working at the different trades. That's how large of a scope of this project was.
The tower was now standing, but it was far from complete. The Sears Tower is not perfectly vertical. The building leans 6 inches to the west. This anticipated lean was caused by the unbalanced distribution of weight resulting from the asymmetrical design. The Sears Tower will return on Modern Marvels. As the skeleton of the Sears Tower climbed skyward, legions of tradesmen waited in the wings for their turn with the building.
There's a positive side to the higher building and the larger project. The top people at all of the companies working on the project were assigned to this particular project. I was dealing with the chairman of Alcoa. I was dealing with the president and chairman of American Bridge. Every contractor was the top executive or chief operating officer of the organization. When we wanted to get something done, we could get it done.
Following on the heels of the ironworkers, work began on the floors.
In a tubular or a bundled tube structure, it's important to distribute the loads, the gravity loads from the building, the dead load of the floor system and the people, the live load of the people, to distribute it as equally as you can throughout the structure. So the idea was every 5 floors rotate the framing 90 degrees. So it would be in the north-south direction for 5 floors, and then it would switch to the east-west direction for another 5 floors.
The lower floors enclosed just over 50,000 square feet of space, a little more than the size of a football field. The floor sizes were diminished at the 50th floor, 66th floor, and at the 90th floor, leaving the top floors over 75% smaller than the ground floors at only 12,283 square feet. 5 sets of 2-story tall floors were strategically placed throughout the building. They were included for 2 reasons: to house the immense mechanical systems and to provide additional integrity to the structure.
Structurally, we found that we could take a lot of advantage of those double height floors by X-bracing between the columns, and it acted like a stiffening element as you went up the building. So by using a very small amount of structural steel for these diagonals, we were able to reduce the lateral drift due to wind by about 15%, which is very significant.
Next, the steel superstructure was coated with fire retardant.
We didn't use asbestos-based fireproofing, even though we could have, and it was cheaper. A decision was made that asbestos could potentially cause cancer. Let's not use asbestos in this building. So we didn't, and that was a very prudent decision, as it turned out.
It was now time to put a skin on the structural steel. Architect Bruce Graham had envisioned a sleek black building made of anodized aluminum.
The price for the aluminum curtain wall was way over budget. I mean, big percentage marks over the budget.
Graham reluctantly looked into other options. An Italian stone supplier approached the project team about using granite for the outer wall, which the company could offer at an economical price.
Bruce and I went over to Rome, and we verified on that basis. In the meantime, I was hearing from my New York office that there were calls coming through from the aluminum suppliers asking what Richard and Bruce were doing in Italy. And mystically, when we returned to the United States, there were new aluminum prices that showed up that were quite a bit less than the granite wall, and that's why the building is aluminum today and not granite.
With the aluminum secured, bronze-tinted windows were chosen to accent the sleek black facade. Over 16,000 windows were installed to complete the exterior. As crews worked feverishly to stay on schedule, engineers had to come up with an efficient way to transport the thousands of future tenants and visitors to the top of the world. The building contains 104 elevators, including 14 double-deckers. These double-decker elevators carry passengers to the sky lobbies on the 33rd and 34th floors, and the 66th and 67th floors, where they can transfer to local elevators. Due to its sheer size, the tower had some other extraordinary problems that needed to be addressed. The unique phenomenon in super tall buildings is stack effect. Essentially, hot air rises and is replaced by cooler air from the outside of the building. The profound difference in temperature causes air on the ground floor to be sucked into the building, creating a massive draft.
The interior air in the building in the wintertime is heated. The exterior air is very cold and therefore the warmer air in the building begins to rise.
Besides being unpleasant, the draft affects many of the operational systems in the building, such as the elevators and the entrance doors. To minimize the problem, the lobby was designed with revolving doors. An integrated airlock system was incorporated at the loading docks to control the amount of air coming in at the ground floor.
As you bring in material from the loading dock, one set of doors open, you move the material into the airlock, that set of doors closes, then the second set of doors open on the interior of the building, and you can move the goods into the building. So there's never a continuous path of open air leading into the building. It's always sealed.
With the smallest of details secured, in the fall of 1974, just 3.5 years after construction began, the Sears Tower was complete.
The key words are in my business: on time and on budget, and we were under on each by a very small margin, but the building was right on. It was incredible that it could be done. This was without computers, and the schedule worked very well.
Sears, Roebuck & Company could finally inhabit their new home. However, their days in their new state-of-the-art headquarters were numbered. The Sears Tower contains 2 million cubic feet of concrete, enough to build an 8-lane freeway 5 miles long. The Sears Tower will return on Modern Marvels. By 1974, the world's largest store, Sears, Roebuck & Company, was now headquartered in the world's tallest building. Approximately 40% of the building was occupied by about 8,000 Sears workers. Ahead of its time, it was one of the first office spaces with robotic mail carriers buzzing through the halls, and a contemporary interior that was scientifically designed to be the most efficient workplace ever.
We thought we did a marvelous job of locating departments that needed to be near each other, next to each other.
With huge 50,000 square foot floors, departments were defined with specific color schemes and interchangeable furniture. But despite the best intentions of the interior designers and the planning committee, there were problems. Some floors were so large that some employees never had an opportunity to look out a window. And moving from the horizontal sprawl of the Great Works to the vertical skyscraper of the Sears Tower was a major adjustment for Sears employees. Some 30 and 40-year-long friendships ended because of the upright configuration of the tower. Some employees only saw people who rode in their elevators.
I talked to people who worked in the Sears Tower, and that's one of the things that they had mentioned to me consistently was that, you know, they sort of lost track of other people in the company being in the tower because sometimes you had to hop over 2 different elevator banks to get to another floor.
Employees lost touch with each other. And more ominously, the company started losing touch with its customers.
Other retailers were nipping at our heels all the time, and Kmart got bigger than Sears and Walmart got bigger than Sears, so by the time we were moving in, we were still #1, but boy, these guys were right behind us.
Based on projected growth figures, by 1998, Sears would occupy all 110 floors. Until then, tenants would fill the upper floors.
The growth that we had seen did not occur. It never occurred. We never got much beyond 2 million square feet.
What they do is they lease the extra floors out, and so it just brought a lot of new businesses and firms and economic activity to the Chicago area, so the Sears Tower really had a dramatic impact.
The once seedy area surrounding the Sears Tower was now booming. But Sears, the retailer, was not. In 1988, the Sears Tower that was built for $175 million in 1974 was put on the market for $1 billion.
People thought the Sears was too big for anybody ever to try to buy, to strip them of their assets. But then came the R.J. Reynolds and a couple of other major buys. People put together deals with junk bonds and a lot of other financing so that it now became possible that somebody would buy Sears and strip off the tower and some other assets. Therefore, the Sears board decided, let's sell the tower and take the money and buy some of our stock back. Let's put it into improving the stores.
After only 16 years in their custom-made headquarters, Sears moved out of the tower and into a complex in the Chicago suburbs. With Sears leaving almost the first 50 floors empty, the new owners made a series of renovations to attract new tenants.
In 1990, when Sears sold the building and moved out, the building was no longer a corporate headquarters building. It was a leased building. It would be 100% leased to tenants. And it became important now that you could directly access the elevators from the lobby.
The elevator system was revised, and the entire lobby was redesigned. Some of the utilitarian travertine and plastic laminate that Sears had installed initially was replaced with stainless steel and granite.
And also a much more obvious entry to the sky deck was provided to try and encourage that business, which is a very profitable part of the operation of the building.
But the lobbies went through yet another transformation. After terrorists attacked the World Trade Center towers in New York City on September 11th, 2001.
Our security after 9/11 has changed dramatically. We have responded with upgrading our security because our tenants, needed to have a sense of comfort.
Well, the fancy security features that you have here are a lot of x-ray machines, metal detectors, and that's really for the safety of the people. It doesn't diminish from what we do as for the friendly, proactive attitude we have, but it does give people a sense of when they walk into the Sears Tower, we are secure.
Employees now gain access to their elevator banks with a sophisticated card access system, which opens sliding glass gates. While improvements to the lobbies were made through the years, the roof had its own additions. Sears Tower was upgraded in 2000 with 4 high-definition digital television combination antennas. An air crane was used to lift the load from the top of the parking garage skyward, about 1/4 mile. Being the highest point in the Chicago metropolitan area, and allowing reception that reaches a 60 to 80 mile radius, the top of the Sears Tower has always been prime real estate.
The Sears building is very unique in its design because it's so big. It's called vertical real estate. And when you're in an area like this, anybody that has a broadcast system or a two-way system or any kind of an RF where they want a wireless system put in, the Sears building was built with that in mind. So they capitalize on it.
Years ago, when the Sears Tower and Petronas Towers in Malaysia competed for the tallest building in the world title, the Sears Tower antennas arguably put the Sears Tower on top. However, in 2004, a skyscraper in Taiwan was erected and captured all the record titles. Well, almost all.
The Taipei 101 building is certainly considered now the tallest building in the world. It is taller than the Sears Tower, roof line, I think by about 30 feet if I'm not mistaken. So we will give them credit for that. As far as our antennas, though, we still have the tallest antennas in the world, and those extend 287 feet above the roof line.
But with or without the antennas, the Sears Tower retains the name of the company that dreamt big enough to build it, and remains a triumph for the people who worked on it and work in it.
It's great when I can look out from 10 miles away and see the Sears Tower standing so tall, and it's great to feel that you were a part of it.
What makes Sears Tower what it is the actual character of the building itself. I'm here, look at me. I stand above everything else that's out there.
It's become a symbol of Chicago. Almost any time you see a picture of Chicago, you might see the Hancock building, but for sure you're going to see the Sears Tower. Still, it's the tallest building in North America, and we can't lose sight of that.